Hello everyone, welcome back to the channel. Today we're going to be talking about slope point form, the third and final format of those linear equations which we started a few videos ago. So you can see that the equation of that slope point form looks something like this. Now it's going to look very similar to that slope equation which we talked about a while ago. I can't even remember what video it was. But really that slope equation was, m is our variable for slope, so we take the difference of our y values and we take the difference of our x values, which we called our rise and run. We divided them. Now that original format in blue can be manipulated to show you how to get that slope point form. So the only difference really is that we're going to use only one point to do this, x1 and y1. We're going to leave x and y as they are to represent the fact that this is still an equation or a linear function where we can have an input of x and an output of y. But the y1 and x1 are going to be just some point that's on our line. So we're going to use slope point form to write this because now I could use this to represent any point, not necessarily the y-intercept like we did with y equals mx plus b. So this one, very generic, and you can use it for any point possible. So we'll take, we'll do maybe just the first ones of these. That way I can leave the other ones for some people to try if they like. So if we take a look at the first one here, the point is -2, 5, and we've got a slope of -3. So the way that that slope point form looks, y minus y1 is equal to our slope, and then x minus x1. Now be very careful, this formula has negative signs built into it. So if you have to substitute in a negative, just make sure that gets changed to a positive, because really we're subtracting that negative coordinate, which will change to a plus sign. So let's go put some stuff in here. We're going to have y minus 5. 5 is our coordinate for y, so it goes in for y1. Our slope is -3, and then it's x minus -2. So here's why that negative sign at subtraction will switch to an addition, because of the double negative. So y minus 5 equals 3, and then this is x plus 2. So there it is. That should be a -3. This is our slope point form. So it does tell me that slope is -3. It also tells me one specific point on the line is -2, +5. I know it's negative because I see a plus sign, and the original formula had a minus. Since the sign is different, must mean the coordinate is the opposite sign. So just keep that in mind here. Now if we take one of them and we try to graph it, and again I'll only do a here, I should be able to take the information given to me in this equation and have enough to draw a line. So the slope is going to be 1/3, right? This is slope point form, so m is my value for slope. That's what's in front of my x's. Now the point, let's just call it point P. Again, it's going to have x and y coordinates. The x comes from inside the brackets. So again, since it's +4, we know the coordinate should actually be -4. Since the formula should be have a minus sign, since it's a plus, that means our coordinate is actually the opposite sign. Okay, for y, I see it's y minus 2, and again the minus is built into the equation, so our y is actually +2. It really is the opposite sign. I have enough for now to draw a line. I have my point, I have a slope. So if we plot this point on there, sorry, give me a second. 1, 2, 3, 4 to the left. 4 to the left and 2 up. Sorry, it's hard to write on the iPad and kind of stay upright. So 4 left, 2 up is my point, -4, 2. And my slope then says to go up 1, right 3. And then I could keep that pattern going, and you can see how we would build new points on this line. Okay, you really only need 2 points to draw a line, but the more you have, the easier it is to connect. And I missed, so let's use the iPad to kind of cheat here. There we go. So there's our line, does connect, and again, it is a line, so make sure those arrows are on the ends, or else it's just a line segment. I know my slope is positive, so I should be going up and to the right every single time, which we are. So there's how we would do that. Take some information from our from our equation and build a graph out of it. So you can attempt B, and I'll give you the full answer key in the description. Okay. Now, conversely, we should be able to go backwards. I should be able to take a graph and actually write it in slope point form. In order to do that, the equation will tell me exactly what I need. I absolutely need a slope, and I need a point. Now we're going to avoid using the y-intercept because it doesn't look like it goes through perfectly, and I really can't be certain. I should probably use any other point that I could see clearly. If I'm going to use the y-intercept, I might as well use slope-intercept form. So for slope point form, we're going to pick any old point. They give me a couple on the grid already, so it doesn't matter which one you pick, but depending on the choice you make, your slope point form equation might look different, so just keep that in mind. It does represent the same line, but the equation might look different. So if I use this point here, and the only reason why is because it's positive, the coordinates are 3, 1, okay, my x coordinate of 3, y coordinate of 1. I do also need a slope. Now since I'm given a graph, I can use the 2 points and count. So up 1, 2, 3. Did I count wrong? I feel like I did. 1, 2, no, I didn't. Good. Up 3, and then 1, 2, 3, 4. So plus 4 for the run, plus 3 for the rise. So that means our slope is 3 over 4, and we have a point of 3, 1. So I have enough to do slope point form. Again, that formula is y minus y1 equals mx minus x1. So we have enough. So we plug in all of our information. This will turn into y minus 1 equals 3 over 4 x minus 3. And remember, even though my coordinates were positive, the equation has minus signs built into it. So I'm really subtracting my y coordinate of 1 and the x coordinate of 3. So it looks like they're negative, but the coordinates are actually positive. Okay, now we're going to take that equation that we had, and we're going to turn it into slope-intercept form. So we did a couple of these before in previous videos where we can convert from one form to another. And we really want to make it look like y equals mx plus b. That's what slope-intercept form looks like again. So that is y equals mx plus b. So if we're going to convert this, I really want to make sure that everything is on one side except for the y. So we just get y by itself. And then I want to distribute some stuff and collect some terms. It doesn't matter if I have fractions or not in slope-intercept form, so I'm not going to multiply everything to get rid of the fraction. I'm actually going to distribute it into the brackets. So y minus 1 equals 3 over 4x minus 9 over 4 when you actually distribute the fraction. Now if I add 1 to both sides, I want to add a special type of 1 because then I have to combine my fractions together. So let's give us some more room here, and maybe a little bit more. Okay, so when I actually add that 1, I'm going to have y equals 3 over 4x minus 9 over 4 plus 1. But right now I can't add those constants together because they don't have common denominators. If I take the 1 and rewrite it with a common denominator as the other fraction, let's use 4. So this 1 will become 4 over 4 instead. Right? That still represents 1. Now it has a denominator which I could use to help me add this together. Okay, so let's go up here, give us a little bit more space. So that means y equals 3 over 4x minus 5 over 4. So here's why I didn't want to use the y-intercept originally when we started to do slope point form. That y-intercept was a fraction, 1.25. So it would be very difficult for us to actually, look at the graph and figure out that that is supposed to be the decimal we're going to have. Okay, since it doesn't line up perfectly, you're always better off not assuming anything, but using a different point to actually figure out the value. Okay, so there's our slope-intercept form. When we started with slope point form, we could have also turned this to general form, but we weren't asked to. So I'm going to leave 2 for some people to attempt. Very much so the same problem, find the slope point form equation, and then write it in slope-intercept form. So you can give that a try if you want. Now here's a pretty common type of question. Given some information, can you create a line? And then can you change it into another format? So I have it's telling me a line passes through these 2 points. We're asked to determine the equation in 2 different forms, one in general form, one in slope-intercept form. Now it's much easier to start with slope-intercept form. You can't really go directly to general form. There really isn't a way. So we'll start with slope-intercept, and then we'll go to general. In order to find slope-intercept form, we need 2 things. We need a slope, and we actually need the y-intercept. If I have 2 points, we can absolutely find the slope between them. So here's our slope equation, y2 minus y1 over x2 minus x1. So plug in some y values. We're going to go 10 minus 2 along the top, which which means we're going to go -1 minus -3 along the bottom. So 8 on top, and that looks like it'll be a 2 underneath for a slope of 4. -1 plus a -3, or minus a -3, sorry, means we add +3, so this will give us +2, our slope of 4. Now neither of these points are actually the y-intercept, and I know that because the x-coordinates are not 0. Okay, they would be if it was the y-intercept. So now we've got to actually find that, which we did before. So let's take our y-intercept form equation. I know the slope now is supposed to be 4, and I know I have 2 points that are on that line. So if I take one of them and plug it in for x and y, I'll have enough information to find b. So here we're gonna let me just move some stuff over. I'm gonna let x equal -3, y equal 2, and m equal 4. Right? M is the slope, and I'm gonna choose point A for x and y. So if I plug everything into here, that means 2 needs to be equal to 4 multiplied with -3 plus b. So 2 equals -12 plus b. Add a 12 to both sides. 14 is equal to that y-intercept. Okay. So now I have a slope, I have a y-intercept. So my slope-intercept form is y equals, my slope is 4, so 4x plus 14. There is our slope-intercept form of our equation. Okay, part 1 of this has been taken care of. We then have to change it so it represents general form. So if you remember what general form looks like, that's the one where everything's on one side of the equal sign. It's equal to 0. Everything is, x is a whole number. The numbers in front of y and the constant are integers, so they can be negative. So the only thing we really have to do here is subtract a y from both sides. So this will say 0 equals 4x minus y plus 14. There is your general form equation. Okay. Satisfies all 3 of those conditions. X is positive, we've got a whole number coefficient. Let's call this slope intercept form. Okay, there we go, slope intercept. You can always convert from one to the other. Now I could have done slope point form as well. I had a slope of 4. I had 2 points of a and b. You could have picked one of them, substituted in the slope point form equation, and had all 3. We weren't asked for it. Usually these 2 are the most helpful. Slope point form isn't used as much, so there's the 2. I won't do the one underneath. Again, it's very similar, so people can attempt that one if you like, and check your solution in that description box, see how you did. Okay, this one again, very similar, so I'll give you a quick hint to start. If you've got an x-intercept of 2, that means your point is 2, 0. If you have a y-intercept of -5, that means your point is 0, -5. So now you've got 2 points, and again, it's the same question. So just worded differently. So again, you can try that one on your own, and you can see how that one goes. There's a couple word problems underneath, which are a bit challenging. So let's take a look. So we've got the sum of the angles at s degrees for some. In a polygon is a linear function of the number of sides represented by n of that polygon. The sum of the angles in a triangle is 180 degrees. Sum of the angles in a quadrilateral is 360. We're asked to write a linear equation to represent this function. So there is a linear relationship between the number of side lengths of a polygon and the total number of degrees inside the shape. So really they're telling us 2 pieces of information, right? They're telling us a few points. Now they are telling me that if I input the number of sides, I should get out of that the number of the angle sum, right? There's a sum of degrees inside of a shape, and that does not look like it says sum. So let's fix that, angle sum. Okay, so really it's representing a point. So really I have 2. If I have 3 sides in a shape, that's a triangle, and I have 180 degrees. But if I have 4 sides, a rectangle or a square, or a rhombus I suppose, any quadrilateral, the sum of the degrees inside is 360. So really I've got my 2 points where the inputs or the independents are the number of sides, the outputs or the dependents is the sum of the angles. So I have 2 points here. I should really be trying to find a slope. So if I find the slope between them, Then I'm going to do 360 minus 180. There's the difference in our y's, so that's our rise. And then 4 minus 3 along the bottom. So our slope is actually 180. Right? So every time I go up a side length, it looks like I have to change this by 180. Okay? So if I actually were to put this into an equation, it doesn't really tell me which one to use. So I'm going to choose to use slope point here. Y minus y1 equals mx minus x1. So there's slope point. And again, the only reason why, purely by choice. General form is not a good choice. I can't go directly to it. Slope intercept isn't a good choice because I don't really have an intercept here. Like I have 2 points. Neither of them are the intercept. So slope point is my best option. Now you could pick any point that you wish. It really does not matter which one you choose. So I'm going to choose 3 and 180 to do this. So my y is going to be 180, but remember that we're representing the output by the sum of degrees. So instead of y here, we're going to write it in terms of the variables provided. So this is going to be s minus 180. So that's the y coordinate I'm using from that point. Okay, equals to m, which we found out was 180. And inside the brackets then, x, our input, was the number of sides. So that's going to be n minus 3, according to the point we have. So here's our equation. If I have a number of sides, I can actually figure out the sum of the degrees no matter how many sides I have. So let's make this look a little bit nicer because I really like s. So if I add 180 to both sides at the moment, s equals 180, n minus 3, and then I have a plus 180 on the end. Okay. If I expand the set of brackets, s equals 180n, 180 gets multiplied by 3 to give us 540. So minus 540, then I still have my plus 180 in the back. So that means our simplified form of this is going to give us 100, let's actually put s. So s equals 180n minus 360. And to make it a little bit easier to work with, let's factor out a 180 as a common factor. So this really says n minus 2. So the relationship here between number of sides and the sum of the degrees, if I take the number of sides and subtract 2, and then I multiply that value by 180, I'll get the total number of degrees inside this shape. Now, this is only one way to represent this. There's actually a visual representation as well that uses geometry and the fact that if you add 3 angles in a triangle, you get 180. That might be a little bit more complicated, but it does make this make a little bit more sense if you're a little more visual. Okay, so for now, this is really what we need, that relationship between side length, not side length, number of sides and the sum of the angles. So that'll work. So now what I can do is I can actually use that equation to help me out for B, right? Because I'm really asked to use that equation to determine the sum of the angles in a dodecagon. Okay, dodecagons have 12 sides. So if I use that, sum of the angles is equal to 180 multiplied by the number of sides minus 2. Now I know that I have to work with 12 sides. So really it's 180 multiplied by 10. So in total, there are 1800 degrees inside of a dodecagon, regardless if it's a regular dodecagon or not. If the sides are the same, or they could be different, there's 1800 degrees in total. Okay, so let's see if we can apply the same sort of logic to the second one here. So I've got, talk about temperature. Temperature in degrees Celsius is a linear function of the temperature in degrees, which is in degrees Fahrenheit. Boiling point of water is 100 degrees Celsius, which corresponds to 212 Fahrenheit. Freezing point of water is 0 degrees Celsius, but 32 degrees Fahrenheit. We're asked to do the same thing, write a linear equation to represent this. Now again, it's going to be super helpful to find a slope. If I can find the comparison between Celsius and Fahrenheit, this is going to make this a lot easier. So I need to come up with some points. Now we do want to make sure that it doesn't really ask us which one to go where. So let's make a choice here. And we're going to say that Fahrenheit will be our x and C will be our y. We aren't really told which, C is a linear function of the temperature of degrees Fahrenheit. So that sentence right there, if C is a linear function, So Celsius is a linear function of Fahrenheit. That means Fahrenheit is the input, Celsius is the output. So the way that it's worded tells us that Fahrenheit should be X, and Celsius should be the outputs, which we know is called Y. Okay, so that's the relationship, how we come up with this F comma C. That's what our points are going to look like. Fahrenheit first, Celsius as the output. Okay, so we're going to have to decide on our actual points here. So we're going to have 2 points where Fahrenheit could either be, if Fahrenheit is 212, the degrees Celsius that corresponds to it's 100. And if Fahrenheit is 32, the degrees Celsius is 0. So there's my relationship between my 2 points. So now I can actually figure out what the slope is. So m equals, we'll do 100 minus 0 over 212 minus 32. Okay, it didn't matter which order I put them, the answer would still be the same regardless. So it simplifies and it works out to be 5 over 9 as the lowest terms fraction. So it'll be 100 over 180, which will reduce to 5 over 9. So we'll do this in slope point form again. Again, purely by choice. So y minus y1. Okay, so there we go. Had a little bit of mic issues. Not quite sure what happened. I'm not sure where we cut out, so I'll make sure this one is in the answer key. And what I basically did is decided on my inputs and outputs. I got my 2 points from, F is the Fahrenheit, C is the Celsius, found the slope, and I used slope point form again. So C was the Y variable this time from before how we decided. Y1 was our one of the points, so I picked 0 and 32 to use and made it a little bit easier because I have a 0. So I plugged everything in, and this equation works out to be C equals 5 over 9, and then F minus 32. So there it is in my, and there my face is in the way, there you go. There it is in my simpler form that will allow us to convert things from Celsius to Fahrenheit. Okay, so we're asked to use the equation to determine in degrees Celsius at which iron melts. In Fahrenheit, it melts at 2,795 degrees Fahrenheit. We got to figure out what that is in Celsius. So using this equation, 5 over 9, F minus 32. If I substitute in the value for Fahrenheit in for F, that means it's 5 over 9, 2795 minus 32. So in total, we end up getting, in the brackets first, I guess we'll do that step, 2763 in the brackets, so a degrees Celsius number of 1,535 degrees Celsius. Quite hot in order to melt that piece of iron. So there we go. There is slope point form. And again, I hope these do make this a little bit easier for you, and you can look back at this whenever you need to. So again, you can look in the description box for those answer keys to any that you tried. You can follow me on Instagram, follow me on Twitter as well at Mr_Saw, and you can ask me any and all questions. I would love to hear from you. But until then, you guys have a great day, and we'll see you back here for the next video.